we have Jean-Michaël Celerier, who is a software developer and the creator of the software Ossia Score, which is a digital art workstation. So that sounds really interesting. So Jean-Michaël is going to present the software, talk about the engine architecture that's under the hood. And yeah, hey, Jean-Michaël, I'm sure it's going to be really exciting. And actually, you are giving a talk live. So this is new for us.
Okay.
Until now, we always had pre-recorded talks. So now we're going to try live talks. So what could possibly go wrong? But yeah, Jean-Michaël, welcome.
Cool. So, well, first, thanks for having me. It's super appreciated. I'll set up the screen sharing. My other. Okay. So my screen should be shared. Cool. So hello everyone. So to quickly present me, I'm Jean-Michaël. I'm from France in Bordeaux. So hello everyone, and hello, there are some people from Bordeaux in the stream. I know there are some. And tonight I'm going to talk about Ossia Score and the Ossia project. So Ossia is a project that was started a long time ago. Like I was 8 years old, so I was definitely not there for the first steps, but I joined it in 2014 for a PhD thesis. And it's a project about basically doing what we usually do with audio in music sequencers, but extending it to other kind of media like video, but also control of other software, control of robots, that kind of thing. So yeah, so this talk will be mostly about introducing Ossia, which is an open source project. Everything is LGPL or GPL, which means free software that you can use and everything is free. And explaining all the architectural choices, in particular, considering that most of the code was developed during the PhD. So there were very tight timing constraints, that kind of thing. So how did we manage to make something that starts working in a relatively short amount of time? And what does the software bring to the audio ecosystem? Let's see about that. So this talk is about audio and, in general, multimedia software architecture. And some details at the end with modern C++. So the whole thing is written in C++, and I tried my best to use the latest standards whenever I could. So I'll have a small rant or retrospective on whether this was a good choice or not, but I'll spoil it was a good choice, I think. Very important thing. So this is a live talk. Feel free to interrupt me at any point. I'll keep the YouTube chat under my eyes, so you can just ask questions, and maybe if Timur or Joshua can ping me on the stream if there is a question I'm missing, because that's what it's for. And most importantly, cheers everyone, big thanks to each other, and big thanks to Josh and Timur and this meetup, which is a very nice thing to exist, especially in these Corona times. So what is Ossia? That will be the first thing. That's my table of contents. Then we'll see the software architecture, and you can follow at the top the little where we are in the presentation. Following the C++ ecosystem, closing words. Okay, let's go. I will first start by doing a demonstration. And so be aware that I will be doing a demonstration on my very alpha current version, so there will likely be crashes. But I think it's important to first show the software so that we all understand what we're talking about. So where is it? Where is it? Where is it? Okay. Okay, so this is Ossia. So can we see it? Let me just check the stream.
Yep, it's fine.
Okay. Okay, cool. So the software is basically a timeline. So you all, I guess, most of you at least know sequencers like Cubase, that kind of thing, Ableton Live. So the difference is that in Ossia, you don't have what is the most basic thing in timeline, which is tracks. That is, in Ossia, you don't have, let's say, your drum track, but you have, let's say, smaller tracks that you can compose in time. And basically, it's a tool to orchestrate various timelines. So you can drag and create timelines like this, and move them, and then you can, of course, drag and drop, let's say, some sounds or whatever. So this creates a few sound files that I'm dragging from the library of Bitwig, which is a very nice DAW. So yeah, so this is a very simple composition of sounds. And I'll just have to connect that. Connect. And if I play back, hopefully, we should hear. Can the stream, is there any sound on the stream? I don't hear it. Okay. Okay, so here I'm playing back. All right, so you should be hearing some sound. And as you can see, there are not one, but multiple timelines. And these timelines can all have their individual speed. For instance, I'm slowing down the first one. But the main point of that software was that it was created mostly for not recording music. For instance, the software doesn't even have an export feature. You can't save your things. You can save the project, but you can't export a WAV file or something, because it is made for live shows. That is, it's used only in interactive context, in concerts, in performance arts, that kind of thing. And to that effect, we have a couple of fun features. The first one being the interactive trigger. So the interactive trigger is something that says, okay, at this point, I want to wait until some kind of external event happens until I continue to the next part of my score. So here, if I play again, it goes here, then it plays this little sound, and then it stops there, and I have to trigger something manually for the thing to play. So by default, there is a 1 bar quantification that I can disable to make things faster. And I could even cut what's before, like that. So the timelines can basically branch in various ways, and it is very nonlinear system. So if you know, for instance, Ableton Live's clip launcher, imagine that it is a kind of merging between both the timeline and the clip launching view of Ableton Live. That is, you can both have sequenced parts and sequenced sub-parts of your score, and also things that are triggered live, but the main view is still pretty much a timeline. The second important thing is conditions. So you can say, for instance, at some point, I want this to only play if some condition is true. And so I'm talking of these external events, conditions, that kind of thing. What can they be? Well, what you will most likely be aware of is MIDI. For instance, you can just say, when I press OK on my MIDI keyboard, well, it will trigger that thing. But Ossia, being a tool for mostly live shows, it also supports a lot of other protocols. This leads us to the second part of the software, the device explorer, which is at the left. At the left, we can add devices, and that opens a small window. In this window, we can see a list of protocol. For instance, OSC, some of you may know it. MIDI input, MIDI output. I don't have any MIDI device plugged in. But also you can use your serial port. For instance, if you have an Arduino, you can just plug it to your by USB and start using it as a sensor or send data to it. Joysticks, remotes, and we are trying to make something that really supports a lot of various protocols and interaction means. And if some of you know software like Max MSP or Pure Data, you know that it's a very common thing to use. For instance, using a serial port to control things, or a joystick, things like that. But the thing is, you will always have to use either different objects in Max, or sometimes if you are using, let's say, traditional sequencers, you'll have to use specific VSTs which support that kind of input or output. The choice we made in Ossia is to streamline everything behind a, for instance, let's see, well, here I don't have any input, but I'll show, or maybe I can plug a keyboard No, I can't play the keyboard. Okay. So just to show what this tree looks like, I'll move on to another score, this one. So in this score, I have a small tree. This is basically a key value map. So you have parameters, and these parameters have value. In this particular case, this is not a musical score. This is a score that will control visuals. These visuals are made through processing. I'll just play it back once, and so that you can see what kind of thing it can do. So let's make that bigger. It doesn't want to get bigger. Okay. Hope it's big enough. Okay, if I play that, you'll see that colors will be changing, and that there are going to be some effects. So hopefully this isn't too laggy on the live show. I'll just play it a couple times again and maybe a bit slower so that YouTube has the time to update. So hopefully you should see the gradient slowly changing and the radius of the ball inside evolving with this automation. And then when these little dots play, you should see a change of state. And all this is like simply OSC messages that are sent. So you say, for instance, this automation controls this kind of OSC parameter. Here we want to send that queue to the network. So yeah, this is basically this part of the software. This is the communication with the outside world. And a last thing is, so here we are only communicating with external software. It could even be on another computer. It could be hardware, whatever. But we also support doing visuals directly within the software. So if any of you know shaders and things like that, you can write your own shaders in GLSL, play videos. And for instance, here I will have a LFO which controls some kind of effect on a video. So like that. So yeah, so it can really be used for the whole breadth of media art, new media art, if you know the artistic field, that kind of thing. And the only thing is that I'm mostly the only developer on that, so it's a lot of work for a single guy. So the reason for doing this talk is if you are an open source developer, if you are interested, if that sounds like a project you want to contribute to, I can really spend a lot of time onboarding you and trying to interest you in being a new contributor. So yeah, so this is it for the main feature of the software. And then we have all the plugins. So the software, of course, supports VST and also LV2 plugins on Linux. I'm a Linux user mostly, but also has its own plugin interface, which basically is needed to support the idea that plugins are not only instantaneous like a VST where you have your input, you have your output, but there is temporal behavior that you can have in plugins. For instance, the curves are plugins, the automation curves. Even the score itself is just a plugin, and you can nest it like that. For instance, structure, scenario, you can drop and you can start building sub-scores and nested scores within each other. You can zoom in a bit and start adding some curves like that, for instance. And then you can save that as a separate file, something, well, if you're used to this kind of software, it's pretty common features, but yeah, you've got unlimited nesting. So you can go as deep as you want and then go back to the upper level and play back everything. You've got plugins for mappings. For instance, if you have an input that comes from a sensor and an output that you want to send, let's say, to the color of something, then you can create, for instance, something with a simple formula, math formula. So let's say you want to take the time and you want to write it to something such as, let's say, what is P1? I don't know what is this part, or I don't know what this is going to do. This is going to explode. P1. Okay, it's not doing anything. It must not be very visible. Let's try white instead. Okay. Oh no, because I'm doing mapping, so I must have an input. So I will be taking as input my ratio, which is computed by this curve, and output it mapped. Okay, and now it's changing things. It's changing the size of the stuff, and it seems to be oscillating pretty quickly. So yeah, and another thing that is a bit different from usual data flow and patchers like Max and PD, where you have cables with inputs and outputs. Here you can also have cables like that, you just drag, but you can also set any address from this device explorer into as an input or an output of ports. And for the programmers out there, you can also use regular expressions if you want to send a single message to a ton of different addresses, that kind of thing. So that is a quick overview of the software. Now I'm going to go back to the presentation. So this software was originally called Ossia Score, and it started as research in the Bordeaux laboratoire, Bordeaux Computer Science Lab. And there has been something like 20 different rewrites over the year, mostly because of organizational reasons. The main issue is teachers have an idea, but teachers, their job is not to write software, their job is to have ideas. So what they do every year is they hire students to write software, except the students only stay 4 months and they leave. And this software, basically, every year there will have been a student which would come for 4 months, and then one until the next year, and then someone else for 4 months. So of course, this is not the same thing. So the first version was written in TCL/TK and C++. There was a reimplementation in Lisp. There was another implementation in Qt in 2006, so that must have been Qt 3. Another in Qt, another in Qt. Then we tried another thing in Juice. Then back to Qt, back to Qt, back to Qt, and this was Qt 4 until 2013, and then Qt 5. And now we are looking at the Qt 6 migration, which should not look too hard. So as a disclaimer, I am employed in a company that is pretty much involved in the Qt ecosystem, KDAB, but I am also leaving that company in 1 week to focus full-time on Ossia. So yeah, so this is basically the family tree of the software, and there are in bluish, this is the actual software, and in yellowish, it's the libraries that the software are using. There were a lot of research, a lot of people doing all sorts of stuff. And to give a feeling of what it is about, here are some pictures of art shows in which it was used. So this is Adhere from Michae. This is Alea. The third one is quite funny. It's a vibrating table used for pseudo-medicinal, well, it's artistic medicine, let's say. So you put on yourself on the table, something vibrates at 10 or 20 hertz, and apparently it does things. The first one is a fun installation which involves 5 mobile phones, and people decide the evolution of this score with their mobile phones. Small user interfaces we have developed on it, and basically it's very interactive and open performance. It's Carré from Pierre Cochard. The fifth one is something that we have a lot of fun with. We control small robots, and we write scores and choreographies for little robots called metabots, which are developed also in the computer science lab in Bordeaux. And we did a show with that last year with someone doing moves in front of a Kinect, and the robots were supposed to imitate as well as they could the moves of the performer. And so this picture with all these nice and very expensive Genelec loudspeakers is a dome. And this is to illustrate that Ossia has no trouble with multi-channel audio. You can, well, the biggest one so far we did was 32 channels, I think, yeah, 32, with sound spatialization. So if you want to use Faust, for instance, if you know Faust, you can use post directly inside Score to use VBAP or DBAP. And this last one is, I'll show a video. This is a project that was done during my PhD. It's a musical merry-go-round. So it's a normal merry-go-round, except that all the places where you sit are musical instruments. And during the round, which lasts 5 minutes, you play music basically. So I will play a small video to show that.
Le carrousel musical est
So this is in French, but
foraine,
doesn't matter too much.
digitale, qui se joue dans un univers merveilleux sous une coque de miroir et de lumière. Dans un univers féerique, un voyage sensoriel débute. Les participants expérimentent les instruments, ils créent une œuvre collaborative. Harpe, accordéon, archet, boucle électro-acoustique, clavier, percussion.
So about this GUI framework question,
Le basilic est une créature mythique du bestiaire
I will have a
médiéval.
slide on this
Il orne
later,
nombre
Fabian.
d'édifices romans et fait le lien avec
And
l'architecture
Eric,
de
yes,
l'église de
they are on the
l'Abbaye
website. I'll give the link
Le carrousel
afterwards.
musical est la cage de ce basilic fantastique.
Archie 3D, yes, slowing the timeline also slows the audio. We use Rubber Band as a library. And just for the small funny anecdote, so this is my desktop computer here. And I had to code during this installation inside the merry-go-round, which rolled. They will do, of course, tests during the day. So after they ended, I still had the head spinning for like 2 hours afterwards, and all day spinning and coding. I don't recommend the experience. Just checking the various questions because I haven't looked too much. Eric, can you name some examples in live performance context? Well, I just did. Slowing timeline, yes, that slows the audio with the Rubber Band library. So there is, traditional time stretch and repitching options. But the thing is, and this makes me very sad actually. So this is GPL, and this means we will never be able to use Z-plane elastic as an algorithm, which of course is very, 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 very good. So unless one day Z-plane says, hey, we are making elastic open source, it won't be as good as the professional offering. And yes, this allows for lighting controls and the stage over. It can output ArtNet directly, but right now I'd still recommend using another software and just sending OSC to a software specialized in ArtNet and DNX because it's a very, very basic integration. Yeah. And yes, so I think it's a third or fourth order for the Embosonics. I have to ask, I'm not sure, but we have a couple of, actually we sometimes use Ambisonics, but we also use various other algorithms depending on the performance. And we have built a system in the lab where you can choose between 5 or 6 different sound specialization algorithms. And Ambisonics doesn't always give the best results. So personally, yeah, more often so people use VBAP or DBAP because it's kinda simpler and much less hungry in resource. So yeah. And to collaborate, the best way will be to come and say hi on the chat. And so I'll talk a bit about it later. There will be an official release starting from by the end of August. We're hoping for, we'll set up some kind of contribution guidelines by then. In particular, what is very lacking is a kind of user library where we will, if you start Ableton Live, for instance, you have all these presets for all the default live plugins, and there is nothing like that here. So this is something that is quite lacking, to have just some simple presets that you can drag and drop. And else, if you know C++, you can also come and contribute, and that will be super, super, super nice. There are like a lot of open bug reports in GitHub. So yeah, so this is it for the kind of installations we are using. And a word to the sponsors. Yeah, the French sponsors are the multiple research projects. We got a small grant from Mozilla and Open Collective back in February. And the very, very, very big thing for this project, so which is not officially announced yet, but you are really privileged to know that, is that we got a mega grant from Unreal, which basically allows me to employ myself full time to work on the project, starting from basically at the end of the month. And of course, all the people who contributed code to the Ossia project, and thanks to them, because so I wrote a lot of code, but I mean, for instance, all the UI parts and all the UI design is a person which is called Akane. There is a lot of specification work done by someone called Pascal. A lot of different people contributed to our project, and really, I would be so happy to see more faces and more diverse faces in that list of people. So I'll just redetail a bit the specific features just so that it's clear for everyone. So the interactive figures basically are these yellow T's, which allow to just how much time do I have left? Am I at 20 minutes? Is that right?
20 minutes is what you'd like?
No, I don't know how if where I am in my.
Yeah, I think we're good. Yeah, however much time you feel that you need.
Okay, cool. So these triggers allow to receive external OSC messages, external media messages, and go to the next part of the score. Conditions, so I only talked about it earlier, allows to choose a part of the score. So it's really, if you are a programmer, it's really programming language elements that we took, that you write like if, while, things like that. And we transpose them into a visual syntax that is easier to use when you are a media artist and not a programmer. So the device explorer, I talked about it, is that part where you have all these values that you can control by OSC, by MIDI, that kind of thing. You can also control the software itself through this. Everything is shown through OSC. And a feature that I haven't really shown is the idea of a graph-based timeline. So if you look at this score, it is really weird in the sense that it makes a loop which goes like that and like that and like that and like that, and it will run forever. And basically, the data model is a kind of state machine. So you can have loops in your score, but not only loops on a single section, but loops across entire parts of the score. Arbitrary nesting, I talked about it. And another important thing, and I think differentiating feature, is that there is a duality between the temporal aspect and the modular aspect. So the idea is that if you look at something like pure data or Max, and most of the people who wanted to make Ossia Score were users of Max. To give the context, the main thing is that Max, if you know it, is an environment that doesn't have any notion of time. It's just a program that executes. And as soon as you want to have a kind of score, it becomes super, super hard. There are better tools like Bach or things like that, but it's still not like having a proper timeline or sequencer. But if you have just timeline, it becomes super hard to compose effects in time. So for instance, I have this small score. Where is it? Example audio graph. So in this score, to give an example of what is possible, we play a sound file. It will loop forever. So here you click on it and there is this little loop button. And its output is connected to two effects. First, a bit crusher, and next, an effect chain with distortion and reverberation. And what Scores allows is to say, okay, for this part of the score, this effect will apply to the sound, and then this other effect will apply to the score, to the sound. And that's something that you write down in the score. And then, of course, you need to connect cables to say, okay, I am getting my sound from here at this point. And another thing is you can have flying things like that. So I have a small curve that I will be able to trigger whenever I want. So extremely similar to clips in Ableton or all these kind of things. And I'm sorry, it's pretty much harsh noise. So maybe I'll try to be careful with volume. Do we hear anything? No, we don't. What's happening? So connected. Maybe that one. Yeah. So here we've got a refresher. And now we're into our system detection. And now I can trigger my automation at any point. And I can retrigger it. And I could do that from an external control and that kind of thing. So let me just check if there are any questions. Yeah, Epic are very, 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 very cool. They're also supporting a lot of other open source projects like Krita, like Godot, which is a game engine. So super nice. And yeah, so shaders is what I showed earlier. So you can make visual, VFX, that kind of thing. And now I'm going to talk a bit about the library that is used under Score, which is called Libosia. So it's a LGPL library. So, and everything is available on GitHub. So here we have the Ossia GitHub. Okay, it's taking a bit of time to load. Okay, GitHub is slow. So Libosia is basically the C++ library which supports the execution engine, that kind of thing, which abstracts all these protocols used in creative coding like OSC, MIDI, that kind of things behind a single API, which is basically a tree, a very, very simple tree. And it has, it has a preset system to say, okay, I want to load a preset for my OSC device on another computer. And it has the whole execution engine. So we'll talk a bit about it later. So, and there are a lot of creative coding bindings of in Libosia. That was the idea, that we will have one library that you will be able to use from any environment you like, and everything will be compatible and communicate together. So if you know any of these names, then you can use Libosia with this. And in terms of software development, Libosia tries its best to match the host environment paradigm. What does that mean? That means that, for instance, I told that Libosia is based on the notion of tree. So if the host programming language like Max has a built-in notion of tree, like patches and sub-patches, then we try to leverage it to create things automatically, and so that it feels very native to the user. So there is documentation online on GitHub. So yeah, so this is the Ossia GitHub. So if you want to help and contribute, this is the first place to go. And then, yes, we have the Libosia documentation, which is on ossia.github.io. I'll send the link somewhere so that you can all have them. Maybe I can write it here. So, and we have all the features on the left, and on the right we have all the ways to use a given feature on, for instance, from Python, from Qt, from Open Frameworks, from Unity. So yeah, and it's always the same features, but under APIs which are adapted to the environment. For instance, if you use Unity 3D, then exposing a parameter to Ossia is just adding a single attribute to your member. So that kind of thing. And there are two C++ APIs, and I won't delve too much on that, but I use the fast one. And another important thing in Ossia is that we teamed up with various kind of consortium, which was led by Vidvox, who make VDMX and a few other software, to create a protocol on top of OSC. So OSC is a protocol like MIDI, but much more general, even through MIDI 2.0 gets a bit better on that regard. And so if you know OSC, you're likely going to like what you're going to see next. So I showed earlier this thing in processing. So processing is a Java environment for creative coding. And in it, we create an OSC query server. And we create a couple of parameters. We give them those sweet names. We say, okay, these are floats. And then what happens? What happens is that you can go, for instance, to a web browser and go to local host. And then you'll see everything as written. And I'm going to use Firefox because Firefox is much better for that. Okay, and with Firefox, we can see all our parameters in real time. And basically, OSC query is a WebSocket protocol to introspect all the OSC parameters of an app. And so Score uses it to basically detect the thing. So here you can just say, okay, add device, like OSC query, and you will see everything that is on your network. It uses bonjour or zeroconf, I don't know how you call that on your system. And you press add, and it detects all the parameters automatically. So you never have to type your parameters by hand. You don't have to do learning, that kind of thing. It just works if both software support OSC query, of course. So that was a very nice initiative. Thanks Witworks for leading this because it makes that kind of thing super easier. So now we are going to talk a bit more about code. First, I'll start with the data model, the architecture, and the architectural choices that were here. So the UI is made with Qt. It's super traditional object-oriented programming, command pattern, abstract factory. We use the observer pattern through Qt's diagonal slot mechanism. And one thing which I am very much dubious of is the model view presenter pattern. So we decided to use that back in 2014, and I was very young and didn't have any clue on proper software development. This is the only thing that I think is, in terms of development pattern, is a mistake. It just makes everything more complicated. We only have one view 99% of the time. Splitting the view and the presenter, it just adds so much boilerplate and so much allocations and shit for absolutely nothing. But otherwise, the traditional OP architecture works very well for plugin-based UI apps, which really makes sense because if you look back at the 80s and 90s OP papers, it was what it was made for. A nice thing is that students can just come and be productive on the code every summer. Most parts of the code are very independent. But yeah, the only thing is there's lots of boilerplate. I'll get back to why later. And so yeah, for future contributors, the software is split in two parts. In source code, you have the lib part, which is independent of the domain of Score. It's just widget utilities, that kind of things. And everything is implemented as a plugin. If you don't have all the parts of the software are separate plugins. And the big thing in the software is not that much. We just have a few widget panels, that kind of thing. But in terms of C++, we are really lacking reflection and back classes. And there is so much lost time due to lacking proper code generation features. And it's very frustrating. So yeah. So now to speak a bit more of the actual data model, the general idea is that it is a tree of processes which mix themselves back into their parents. So here in this simple example, you've got the automation, which is nested inside an interval with line. Interval is nested inside a scenario, which is temporal organization, which is nested into interval, blah, 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 up to the root level. And the root level is the same kind of objects than every other array. We try to make something that makes computer scientists happy with, let's say, very simple data model. And it's a bit similar to patches and subpatches in Max and PD, except that we are not file-based. And then, so we have this first tree, and then we have a kind of graph for the timeline. So these are all the elements of the timeline. So I talked a bit about them. So the states are for sending a single message at a given point in time. Condition, it's an if-else. Trigger is for event handling. Time sync is to connect things vertically, and interval it's the horizontal line that you saw. And now, if we dig a bit deeper in the engine, so there are a lot of various approaches. So the very first approach didn't even have audio, and that's very interesting for music software. It was developed in a music lab, but up to 3 years ago, there wasn't any sound that will get out of it because all our user base were people who were doing more performance art, theater, that kind of thing, and they didn't need to play a sound, or they would use another software when they needed to play a sound and send a message, OSC message to it. That made me very angry because I am a musician and I want to do music. So it was frustrating to work on that software and not have any kind of audio processing. Then at some point, we started looking at Libosia, which is a library made in Gram. So if you know the first programming language, it's the same people. The model matched well the first version of Score, but then we started adding features and it didn't match anymore. So we had to rewrite our own stuff from scratch. Story of my life. And so the very specific thing in terms of implementation of Score is that it's a dynamic data flow graph. That is, the data flow nodes vary in time. There will be a nice schema afterwards. But depending on the point in which you are in the timeline, for instance, if you are at this point, you have one data flow. And if you are later at this other point, you have another data flow. So there is a lot of work in making this data flow switching process kind of efficient. And otherwise, the implementation itself is not very big. It must be like 10,000 lines of C++. It's really not that much. It uses Boost, it uses everything it can because, as I said, I was mostly alone doing the meat of the development work. So any library was good to use, anything that will save me a couple hours of coding. A very important thing is that we were also using TBB, which is a library for parallel graphs, and recently migrated to Simple Task Flow, and that gave us a very, very, very neat 8% performance boost. And it's also header only, if you know the pain of building C++, which just makes it so simple to use. Another important thing is how do we make it so that you can edit the score while we play, and now we are full into C++, so we are using the library which is called reader writer queue from HTML. Very nice log-free queue, but I will let Timur talk about everything log-free because I think that is part of what his talk is about. But yeah, we just have queues of exchanges messages between threads and some manual garbage collection, for instance, to make sure that we don't have any kind of allocation on the allocation, especially the allocation in the audio threads. And so this is a quick schema of the audio architecture. No, okay. So yeah, so to give a summary idea of how things work, so we have a data model in the UI thread and an execution model in the execution thread or threads, and they communicate with this chain of commands, and that is surprisingly extremely efficient. But never saw that crop up in any kind of profiling bottleneck, so that was neat. And finally, the big question is visuals. And visuals is yet another graph. So to explain a bit how graphics work, when you are doing graphics in 2020, you are trying to use your GPU maximally because the GPU is super powerful. So you really want to use it to its best. And so we have neat APIs such as Vulkan, Metal, Dr3D. And those APIs work by basically sending to the GPU a list of things to do. And how do we generate a list of things to do with the GPU? Well, a very common way is by a graph. That is, we have a graph of the things we want to do that the user positions in this software as you saw. And then that gives us a list of commands sent to the GPU. And it's another thread, so I'm starting to be a bit anxious with all these threads in the software, also video decoding threads, that kind of things. But so far, this hasn't caused too many problems. And we also tried to separate things a bit and be like more Unix, let's say, Unixy in the sense of having separate processes. But for instance, playing back videos in an external process, that gave us a bit too much latency to our liking. So maybe there were like coding issues, but yeah. If things are too blurry, or if my accent is too French, I can repeat, or I can talk a bit about.
No, it sounds and looks great.
Okay, cool.
You're all good.
All right. And so how does it work? So for visuals, so we have our graph in the audio thread. And when the visual node graphs, there are some shim nodes for the visual graphs, they get a token and then they send it through the same message queue mechanism to the visual thread. And well, that just works. So how does everything work together? So first I will show a schematic in Bix. So where is it? Where is it? No, did I lose it? Okay, I lost the picture. No. Okay, I'll stay on that later. Okay, so this picture at the left is very small, I'm sorry. It shows a simple graph, a simple score with two parts. The first part has an automation which loops. This automation goes inside a mapping, which applies a kind of easing function. And the mapping is sent through an OSC message to some external light intensity control. But note that there is a small C at the beginning. I'm gonna see if I can just open that picture bigger because it's horrible for you guys. I'm sorry. Yeah, this one. Okay, this should be there. Okay, so we have this automation which goes inside the mapping, and both the automation and the mapping send an OSC message because the mapping may or may not be active depending on the condition. Then after a while, we play a sound, and at some point, we may send the output of the sound inside an effect. But we also want to play the sound if there is no effect. So what this means is that we have actually a lot of various possible data flows in this score. A lot of different possibilities can happen. Things can be triggered or not. And these are all the graphs that are generated by software. There is the hierarchical graph, I talked a bit about it earlier, the data flow graphs, and the temporal graph on the right, which is basically how things follow each other in time. And when I did this slide, there wasn't visuals yet. But if there was visuals, there will be yet another graph just for what's being sent to the GPU. And if you are interested in the actual software architecture, we have a how do we say, UML model, which is not entirely up to date, but is still pretty much relevant. So it is in the Git repository. It is score.q model. And so yeah, it's a good starting point if you want to understand how things are organized. So it is opened in the Qt creator. And I spent quite some time doing this and explaining all the, all the relationships between different classes. So if you are lost at some point and you want to contribute, this is a good place to see how every class relates to each other, because that's the drawback of OOP design. You get a lot of classes with very small responsibilities. So that makes a lot of names. It's the kingdom of nouns problem that some of you may know. Yeah. And one last word on that, synchronization. So a common problem in audio processing is how do you synchronize, let's say, MIDI messages very precisely in your buffer with audio. So this isn't done. There is a lot of research on that, done, for instance, by Ross Bensina. So if one day a user asks us about that, then I'll start looking into implementing it. But so far, no one has complained. So yeah. And so to answer the thing, so I wrote, let's say, 90% of the code, but there is a lot of research, and there is a lot of people involved. And also, I am quite lucky. There hasn't been too many bugs so far, but I can guarantee that like it's still buggy, sometimes much more than Ableton Live. So yeah. So now I'm going to talk a bit. How much time do I have left?
I think just a couple more minutes, maybe.
Okay, so I'll just skim very fast, and if we want to talk about it,
yeah.
It's just to talk about a big choice here was to use C++ and follow modern C++ very, very aggressively, because my very, very naive young self idea was, okay, if we use all of these fancy pants new features, everything will work fine and will be fast. And so the language features, for instance, C++ 17 are super nice. If const expr, full expression, move semantics, which are from C++11. Auto is super nice because you just don't have the time to type types when you are doing a thesis. So, and my experience with almost always auto is every programmer who started in projects was like, no, auto is shit, I don't want that shit. And after 2 months, everyone was like, auto is fantastic. So that is my own personal experience, that everyone always get converted to auto when they are on an actual project with a lot of stuff on it. The language feature I'm looking for are those, but the one I want is breaking metaclasses, because like 20 to 25% of the code could just go if we had these code generation features. And then there's library features, and just a quick word. Variant, bad. A very, very, very core data type in Ossia is a variant of integer, float, ball, string, blah, blah. It's everything that we store in our message tree. And at some point, we were using X variant before stud variant back 5 years ago. And the debug size of the library was sometimes around 1 gigabyte. And the release build was around 3 megabytes. So there was like almost 98 megabytes of debug symbols because of that. So I had to write a code generator to just generate switch cases beforehand, because, yeah. And I hope stud variant will get better with time, but I'm not convinced. And super sad to have stud optional without references, because it was used. So we are still on the boost optional, which supports references. And yeah, I will skip that because there is not enough time. A big question that I know, and I hope I am not offending the sponsors. Juice is super fine, but an older version of Score used to use Juice, and the performance was very subpar. We needed to do everything anyways, and myself, I knew Qt better, so I went with Qt for writing it, because just question of time. I think I'd still be using Qt today, but mostly because it comes with a lot of additional libraries, like for HTTP, WebSockets, the tree view is super fast. There is QML for scripting that you can use in the software. So you can, well, I haven't talked about this, but you can add basically JavaScript code and run it during the timeline. So yeah, so that's it. But some things are quite bad in Qt. Bug fixes are slow. My first bug report took 2.5 years to be fixed and be merged, so very terrible. I suppose I won't talk about it. Compilers, during my PhD, I reported 40 bugs on MSVC, 10 bugs on binutils, and a few on GCC, and just 1 or 2 on Clang. So now I just use Clang everywhere on Windows, and I never use MSVC again. I lost like 2 months of my PhD just working around MSVC bugs. That was very, very bad. Check heap track and hotspots, which are very, 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 very nice tools from KDAB. They are 3 super nice profilers for memory and from performance. And okay, I won't talk about that. It's too, well, one last thing. If you want to see modern C++ in action, so I know, Corentin, you will like that. So there is a part of Score which allows to write kind of compile. So we want to write individual plugins very fast. So if we take the game plugin, basically we specify a data structure which gives us the inputs and the outputs. And then we have something that generates a function that, well, checks it at compile time with, checks that it has the right inputs and outputs considering the specification given here. And if you are used to writing max or PD externals, you will never get a typing error here. You will always get the right types and never make a mistake. But the drawback of this is a file with a lot of commas and a lot of, yeah, code looks like this. So, but it's not that much code. It's like 400 lines of code to parse this, mostly using C++ 17. That was not possible before. So yeah. Next step, I want to talk about this. There is a roadmap on the website. So important thing, website ossia.io. We are going to make it, but for now, yeah, roadmap. Blah, 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 blah. So everything that we are going to do next. And one last thing. So thanks for listening. I hope I'm not too late. As you all know, we open source maintainers feed on GitHub stars. That is, tonight I'm going to make myself a nice meal of GitHub stars. So please start GitHub repo because that is my main meal. And more seriously, we have a chat and you can come and say hi. And if you have bugs, whatever, try to be here most of the time when I'm not working. So yeah, thanks everyone. So I'm going to check. Why not Qvariant? Okay, why not Qvariant? So one thing is Qvariant may do some memory allocations if the type is too big. And also Qvariant, I mean, it's nice if you are, one thing very important is Ossia Score uses Qt, but Libosia doesn't use Qt at all. It's just raw C++ 17, as there is not a line of Qt in it except for binding. I wish people would get paid for stars. And other than that, yeah, Qvariant, well, it doesn't have the performance characteristic that we wanted for real-time system. Well, there are no real-time guarantees on Qvariant, while a stud variant of int float, well, there is no magic that happens. And in my implementation, there is just a switch case. So yeah, that's mostly why not Qvariant. And also there are often pretty bad bugs with Qvariant. So personally, it's a class I don't like too much. Well, sometimes when you're doing UI work with Qt, it's the class to use. But if you are not doing UI work, but backend work, I will not use Qvariant. So yeah. How do I approach testing with us? So I actually have a fair amount of tests. And so Libosia, we can have a look at some. So for instance, let's say for the execution engine, I have some small scores that are written in code. And I think I have some, no, I don't have them, but yeah, for instance, and I make very cute ASCII schemas of the score I'm writing, and then I'm writing the score in code, and then I have all my if 5 time units elapse, then I am in this state, etc., etc. And yeah, that's mostly that, and then testing individual things, but it's still super hard. And it's really, so if you want to contribute by writing unit tests, you are the most welcome person in the world, because that is a soul draining work. And of course that helps, like for all the engine work, I always start by writing the test first when I do the feature, because it saves so much bugs. It's incredible. But sometimes it's so hard, and a lot of times the specification change when talking with artists. So we had to go through everything like dozens of time to rewrite the test, and super frustrating. And yeah, one thing that is harder to test is the network communication, because for instance, on Travis CI, when you have timeouts and things like that, and sometimes tests just don't work, and that's very frustrating. But for instance, what we do is, let's see, OSI query color test. So yeah, so for instance, we can send colors, and we check that we get a correct JSON on the other side. We check that basically everything is in the state that it should be, but there is still a lot of work in that. And yeah, but write unit tests. Unit tests are good.
Great.
So yeah, thanks everyone.
Yes, thank you very much, Jean-Michaël. Wow, this is, I know that several people in the chat have talked about how their mind has just been blown with the size of this project. And how many contributors do you have on this project? So how big is your team?
So the very core team is 3-4 people, depending on who you ask. So I do most of the code. There is Akane, who is doing a lot of graphics and is also working on the website. So we're getting a super beautiful new website. It's not official yet, but it's so beautiful. I want to share it. Look at that. It makes me cry. We have Pascal, who is an artist who has spent a lot of time writing specifications for Score according to his own artistic practice and how we want it to see. There is Miriam, who is a researcher who had helped a lot on the formal model side of things, because during my PhD I had to write that in a much more formal way. So I had to write the model in OCaml, for instance, and she really helps a lot with that. And then we have Antoine, who helps more with writing Libosia and Libosia bindings, for instance, for Pure Data and Max. And Thibaut, who is doing writing examples and running workshops, teaching like music school students how to use the software.
Amazing.
So
Yeah.
Do you mind unsharing your screen? I don't know if I can do it from my side.
You can share my face or...
I think you have to do it, right?
Yeah.
You have to click on...
Who I have to do it.
Oh, right.
Yeah, there we go. Great.
So yeah, thank you so much for this talk. This is a huge and impressive piece of work. So yeah, I'm also one of those people whose mind is blown.
Oh,
yeah.
And, in addition to that, I really liked everything you said about modern C++ and unit tests and writing tests first, and the fact that you use Catch for unit tests, which I also noticed.
So I used to use Qt test, and I migrated to Catch, and Catch is really, really much better.
It's great. So yeah, all of that stuff. Total agreement from me.
Nice.
We have a few questions on the chat, but I think you actually answered quite a few as well.
Yeah,
so
I tried to do.
I'm gonna start from the start, and if there's something you already answered and I missed it, then just let me know. So I apologize in advance. Okay. So there's one. Stu is asking whether, obviously, with this being a tool for live shows, whether it also allows for lighting controls in other stage hardware.
Yeah. So I quickly answered it, but yeah, you have a lot of protocols to. Well, that's what people were doing first when they were using software. They were not doing music or audio; they were just controlling robots or things like that. So yeah.
Cool. And then speaking of that, so you had quite a few of like performances that were made with this that you mentioned, and people were asking whether you could like post maybe later on the chat, just post the names of them.
Yeah.
Look them up because they seem to be like really interested about them. So
there is a gallery page on the website. I will be writing that on the chat. Up. So yeah, so all the pictures I shown were taken from this, and most of the performance have linked to the actual things because it's super important to give credit to the artists. And that is one very nice thing to contribute. If you ever make an artwork with the software, please send us like one picture, one name, something that we can show that it's being used in the real world, because in the art domain, you really need validation by the peers. So please.
Right. So here's another question from Fabian. I think that's really interesting because you said you tried Juice before and then you settled with Qt. So obviously went through quite a lot of like GUI frameworks.
Yeah.
And you settled with Qt for the reasons you named. But if someone else would start a new project on like a similar scope, which UI framework would you recommend?
So for what I want to do, well, Qt has the nice thing that it's pretty big and it's pretty well maintained. There's a lot of people backing it. Like there's, I think, 300-400 at least recurring contributors to Qt. So it kind of feels safe in that way to use Qt. And I mean, I've worked in a company where we have Qt running on car dashboards. So if it crashes, people die. So that makes me safer to use it also for that kind of software. Then Qt also comes with a fair amount of drawbacks. So some of you know, for instance, the meta-object compiler. So I personally don't use it. I use a library which is called Verdigris, which allows to use just C++, no external compiler. And then there's I'm surprised no one asked that, but there's this Rust question. Rust is this new super nice programming language. So there are a couple of things that are still missing for me in Rust, and namely a big UI framework like Qt. But if someday Rust has something like Qt a bit, then it will make a lot of sense. What will not make sense, I think, are simpler UI frameworks like adhere EMGUI or things like that, because we use a lot of very specific UI widgets. For instance, the tree views performance was per mount. We have some artists who have 15,000 parameters who update in real time. And that was an issue with, I remember, with Qt, having thousands of parameters just all updating at high frequency that will put it on its knees, and Qt eats that like it's breakfast. So yeah.
Right. So Nico has a question about the DOM installation that you showed, which looks like an ambisonic system. Do you know which order?
Yeah, I think I answered that one already.
Oh, you answered that.
Yeah,
Sorry,
yeah.
I must have overheard that.
Oh, to Gasper Asman's question. Well, what I've been working are the speed indicators. So if that way, if you don't see your speed, that can be super dangerous. But yeah.
All right. So I think you answered the remaining questions. I might have overlooked one or two, but
okay. Well, if there is anyone who hasn't had his question answered, can